In 1994, neuroscientist Wolfram Schultz placed electrodes in a monkey's midbrain and watched dopamine neurons fire at peak intensity the moment a light flashed, before a single food pellet arrived. And researchers still cannot fully explain why the human brain treats the anticipation of a reward as neurochemically identical to the real thing. That is not a metaphor. That is a measured chemical event. And it is happening inside you right now. Schultz was not researching addiction or willpower or self-sabotage. He was mapping something far simpler: how animals learn to expect a reward. A light, a lever, a pellet. What he found instead was a system running on rules your brain has followed your entire life, rules you were never told about. The structure at the center of this is the nucleus accumbens, roughly marble-sized, buried at the base of the forebrain. It does not care about your long-term goals. It does not weigh consequences. It has one job: respond to the signal. And here is what makes that dangerous: the signal has almost nothing to do with reward itself. This is what Schultz's recordings showed. When a monkey receives an unexpected reward, dopamine spikes sharply, intuitive, but run the experiment repeatedly: light pellet, and the spike migrates. It moves backward in time. Eventually the neurons fire not at the reward but at the cue that predicts it. The light, the notification sound, the package tracker updating. And when the expected reward fails to arrive, dopamine does not stay neutral, it falls below baseline. The brain does not return to zero, it goes negative. The system punishes absence with chemistry. The easy interpretation is that this is simply learning, Pavlovian conditioning made molecular. The brain anticipates reward and pre-fires to prepare. Tidy, rational, adaptive. That explanation held for years. Until Kent Berridge at the University of Michigan spent a decade separating two systems researchers had assumed were one. Dopamine, Berridge found, drives wanting. A separate opioid circuit drives liking, the actual experience of pleasure once the reward is received. They are not the same system. They do not exchange information the way anyone assumed. Berridge chemically disabled dopamine function in rats. The rats stopped pursuing food, stopped pressing levers, stopped chasing entirely. But when food was placed directly in their mouths, they ate it, and their pleasure responses, their facial expressions indicating genuine enjoyment, remained completely intact. They could still like. They simply could not want. Wanting and enjoying are neurologically separate. The system that makes you pursue a thing is not the system that makes you satisfied once you have it. And that is where the problem lives. Because dopamine is a pursuit signal, not a satisfaction signal, the architecture is permanently pointed forward. Your brain is built to value what it does not yet have more intensely than what it does. Not because of a malfunction, because of the design. Researchers call this temporal discounting. A reward arriving in 10 seconds fires the system harder than an identical reward arriving in 10 minutes. The same reward delayed by a week produces almost no dopamine response at all. This means your brain runs a constant calculation you never consented to, one that makes future things chemically invisible. Long-term plans compound growth, relationships that build over years, they register as almost nothing compared to what is immediate. The notification, the click, the hit of recognition, not because those things are more valuable, because your dopamine system cannot perceive future value at the same resolution it perceives the present. And this is the part researchers have not resolved. The system cannot be argued with. The prefrontal cortex, the seat of long-term thinking, can suppress dopamine responses, but it does so at cost. Every act of suppression draws from a finite resource. Willpower depletion is not a concept. It is a measurable biological event. Judges issue harsher sentences before lunch than after. Surgeons make worse decisions late in a shift. The capacity to override the dopamine loop is a fuel supply, not a character trait. The obvious answer is discipline. Train yourself to override the signal. Build systems. That is the argument behind nearly every productivity framework and self-help manual written in the last 50 years. But discipline draws from the same depleting resource. And your dopamine loop does not deplete. It resets overnight and starts again. The environment is not neutral either. Every feed, every interface, every engineered food product was built by teams who understood this mechanism precisely, who designed reward signals calibrated to fire your anticipation response as frequently as possible, while delivering as little actual satisfaction as the market will tolerate. That mismatch is not accidental. It is a business model, which leaves the question Schultz's original data never answered. If the system is built to pursue and never fully arrive, if wanting something and having it run on separate circuits that never synchronize, then what exactly does your brain think it is working toward?